Okay, we're live. Hi everyone, welcome to this week's Antrea live show. This is the third time we invited folks from Beijing team to join us, and today we have Jiajing here. So, would you like to tell us a little bit about yourself, Jiajing?
Oh, hi, I'm Jiajing. I'm engineer in VMware. Thank you.
Okay, are you excited about coming to Antrea live?
Yes, very exciting.
Awesome. So, okay. And also, today we have our old friend Yang join us, and he will tell us a little bit about the multi-cluster network policy, right?
Right. We're going to talk a little bit about the first part of network policy support in multi-cluster environment, and the first step will be to replicate policies across clusters, which I'll diving a little bit deeper. And in the future, we will also have stretched policy, which means you can apply policy across for traffic across clusters. So this is still a work in progress, but stay tuned on that. Maybe in like 10 Antrea live from now, we probably be able to demo it. So
Okay. Okay, we are looking forward to that. Okay, so let's first start with the an Antrea CLI and cutoff.
Okay. I will share my screen.
Mhm.
Mm, can you see my screen?
Yeah, we can see your
Okay.
screen.
Today I will make an introduction to the Antrea CLI. That's which called Articato, and we add some new features in Articato. First of all, let's review the let's review how to deploy a multiple cluster set. According to the user guide, deploy a multiple cluster set can be divided into several steps. First of all, we need to deploy the multiple cluster controller. Um, in a cluster set, there will be one leader and two or more member clusters, and we should run on the multiple class controller in every cluster. So, so we can do the following steps to running the controller. For the lead cluster, we can apply we should apply two YAML files in the cluster. That is called Antrea multi-cluster leader group YAML, and Antrea and this YAML file contains contains all the CRDs which is needed in the multiple cluster. And then after apply the Antrea multiple cluster lead global YAML file, we should apply the namespace YAML file. You can see this Antrea multi-class lead namespace YAML file. These YAML files contain some other resources, namespace resources that we need in multi-cluster, such as deployment, service account, cluster role, and role binding, and so on. And that is lead cluster. As for member cluster, we should also apply the Antrea multiple cluster member YAML file. About this file is maybe familiar with the lead cluster. And after we do this, we can see the multiple class controller running in all clusters. But it's only the controller is not enough. We should set up a class set in order to use the multiple class features. So we should create a class set. That is the section class set creation. The first step to create a class set is create the access token in lead cluster. All all the member cluster need to get the access token. So in order to access the lead cluster, so maybe in this lead cluster we should create several resources. The first one is a service account, and then we should create a secret and a role binding. A role binding is a bind the service account to the Antrea MC member cluster role to get the to make the lead member cluster to can access to lead cluster, and then after we do this, we should save the secret to file. We can see the next step. Get the member token. The member token is the token we create just now, and get the name data we needed, and then apply it in member cluster. In this example, we create a secret for member East cluster. So we should apply it in the East cluster. And then this is an example for East cluster, but some other member cluster such as maybe West cluster and South cluster, we should do the same thing. So maybe if you have one member cluster, you should do this one time. If you have 10 member cluster, you should do it 10 times. And then after we do this, we should set up a cluster set. A cluster set is all cluster in cluster set is use the cluster claim to claim itself and as a member of a cluster set. And a lead cluster will define a cluster set which include the lead cluster and all member clusters. In member cluster, they just need to claim itself and the lead cluster. So let's see the YAML files. This is a cluster set template in each cluster. We should at first we should claim the each cluster itself. Is this section is a class claim, and then we should claim a cluster set, this one, and then we should set the lead cluster ID. The secret is created just now, and then we should set the server of the lead cluster. This is the address of the API server. This is for each cluster, so we just need to add the each cluster ID in the members. After we do this, the claim in the each cluster is done, but it is not enough. We should this is one lead cluster member cluster. In other member cluster, we should do the same thing. Maybe for example, there is another member cluster called west member cluster. We should change all the east to west. That two member clusters, but if we have more, we should do this again and again. After all this were done, and we should plan all the member clusters in lead cluster. So in the architecture of multiple cluster, all the member cluster will communicate will do resource export and resource import across the lead cluster. So the lead cluster all the member cluster will be registered in lead cluster. And so we can see this YAML file. This is familiar with the one before, but it is a little different. You can see this. The member in the cluster set in lead cluster, we should also create the class claim to claim the lead cluster itself, and then we should create a class set. In the class set, we should the lead cluster only contains the lead cluster itself, but the member clusters we should contain all the member clusters, and for each cluster we need to set the service account. This service account is the secret. When we create the secret, when we have created the service account. This one, member is to access to a service account, and this is the member is to access service account. This. Maybe set create a class set is not easy. I think we should do the same thing again and again, and sometimes we will make a mistake, so the class set is wrong. Is not, and we cannot use the multi-class feature. So there in the meanwhile there Antrea has command lines tools which is called Antcato, and maybe use Antcato to manage the multi-class feature is a good way to solve this. So we tried to add some new commands in Antcato. You can see.
So the user guide here is for users with Antrea 1.6, right? So if they use Antrea 1.6, they need to follow this document and do all the create all the resources manually, and then test if all the settings are correct.
Yes.
Okay, and then in future release, we have the Antcato, which automate all the steps here. So you just need to like 1 or 2 commands, and all the setup is done.
Yes, but maybe not 1 or 2, maybe 2 or 3.
Okay, so it makes this setups process much easier, right?
Oh, okay, yes. We can see this issue. What we want to is use the Antcato to set up and manage the resources in multiple cluster. So the design is add a subcommand MC. MC means which MC means is multi-cluster. So user can run Antcato MC verb to get resources, create resources, deploy the class set in CLI rather than by YAML files. When I was newer in Kubernetes, I think YAML file is very complicated. Once we add when we added the YAML file, we found it is difficult. So maybe in CLI is a good way to solve this. In the early stage, we will add commands such as Antcato msget to query resources in multiple cluster. And this command is available in Antrea and 1.6. It is okay. And then we will add some more commands such as Antcato deploy, Antcato MC add, Antcato MC create, and Antcato MC delete in the future, maybe 1.7. The MC deploy is used to deploy the multi-class controller and the CRDs, and Antcato MC add is add a new member class to the class set. Let's see the use guide. The member cluster is the definition of the member cluster is in the YAML files. It is an array. Once we want to edit it, we should get the YAML files and edit it and apply it again. But when the YAML file is too long, it's not easy to edit it, and such as maybe there are so many member clusters, and we should add and delete often. Maybe it just add the YAML file is not easy. So we add some we add some two new command, that is add MC add is used to add a member class to the class set, and add MC delete, which is used for offboarding a member cluster. There are some features supported.
I have a question for the MC delete. So it's saying that it delete the resources in the cluster set. Does it mean that we can remove a member cluster from the cluster set?
Yes, we can remove a member cluster.
So the MC delete is to remove a member cluster from the cluster set.
Yes, and it also can be used in delete the class set itself.
Okay. So it's like if I do the MC delete with the name of the member cluster, I delete the cluster and all the related resources. And if I do the MC delete cluster set, it means that the whole cluster set is gone.
Okay. Yes.
Okay.
Other MC should support below features. Initialize a lead cluster. Maybe let's see the use guide. When we deploy the lead cluster, we should at first we should apply the Antrea MultiCluster lead group YAML file, and then we should create namespace and get the YAML file by call or maybe by get, and then apply and then change the namespace and then apply it. But in the command line, we should only do one thing, that is add MC deploy lead cluster. Maybe there are some flags, maybe namespace and version and some other files. For example, we should only do this. Add MC deploy lead cluster Antrea version and namespace. Then all the CRDs and the controller will be deployed automatically. The second feature is offboarding a member cluster. Add MC delete member cluster. This is easier for user to delete offboarding and member cluster, especially when the member cluster is too many. If there's too many member cluster in the class set, maybe delete one or more class set is not easy by add file. So this command is maybe easier. Member cluster can only created by add 2. This is add MC deploy member cluster, same as the lead cluster. Then join the member cluster. This one is familiar with this one. Maybe sometimes we, for example, some user will have many clusters, and the cluster will online and offline. Then editing YAML file is, I think it is not easy. So maybe we can use delete and add to do this. But now only the article MC get is available, because some other feature is in development. So maybe I can just do a little YAML file, do a little demo to show the difference between get and control and art control to and see how the art control works better. Okay. I have 3 clusters in hand. I have already deployed the MultiCluster controllers. So I will do yes.
So the east, west, and west are the
Yes,
member
there
clusters.
are yes, there are 3 clusters, which is called leader, east, and west. There are served YAML file. It's easy. It is simple, maybe that
A
service
service and a service export.
export. Okay.
Yeah.
I will apply it in the. Oh, sorry. Actually, okay. Just wait a minute. Sorry.
Okay, so if you apply this YAML file, the service and service export will be created. And
Yes.
what's the next step? So what's the next step?
After I apply the YAML file, the service and service export will be created, but in the east cluster, and there will be service export import in the west cluster. So we
Okay, so the expect behavior is that after you apply the YAML file in the east cluster, we should see the same service in the west cluster.
Okay, I have already. I have already played. Okay.
Okay, so this is the one that
the cluster is not ready now. We can.
Yeah, let's give it a few more minutes.
We can get the resource import and resource export by kube control. So okay, this is the resource export. In the lead cluster, we get the resource export such and the output is like this: namespace, name, and age. We can what information we can get from the output? What I just know it is the resource export and the name, and in namespace Antrea MCSNS, but we don't know any other information now. If we want to get more details, we should maybe we should do this. We should output the YAML file. But if sometimes we just want to know some more information, not rather than YAML file, because YAML file there's too many information we don't need, such as create templates and maybe some other information we don't need. There will be all the output will from my screen. So maybe I don't think it is a good way. I will use the Autocad.
You spell the kube config wrong. Yeah, there's an N missing in the kube config. Yeah.
Oh, sorry. Okay. We can, when we use the Autocad mstat, we can get the same output now, but there's more information. First, we know that it is the output of the cluster set that is cluster east, and then we know that there are two kinds of resource exports. One is endpoint and another one is service. But when we use the lead cluster we can only get the name and the namespace. I think at Carton, there are two resource exports. But if we have more, maybe Articato will get more information and we can get the information directly and easier. That's the maybe a little advantage of MultiCluster Articato msget. And in the 1.6, only Articato msget command is available. But in the future, when we will deploy, maybe we can use the Articato mc deploy with cluster to deploy the cluster set. And this feature is under development. And to be honest, my cluster set is set up by the command line rather than YAML file. So in my experience, I think it is more easier.
Yeah, it's much easier because you don't need to go through the long user guide. You just need to for magic command to make everything happen, right?
Yeah.
Yeah. So the encodel mcget gives us more information, but the 4 commands coming up in the next release really make things different.
Yes. Okay. That is my short a little introduction to the Articato MC command. Thank you.
I'm really looking forward to the 1.7 release, so we can get everything much easier and really improve the user's experience.
Okay. Thank you.
Okay, thanks, Jiajing, for the introduction of Antrea and Color. So let's move on to the other topic. So there's another one that is related to MultiCluster. So the Antrea support MultiCluster Service, we also support MultiCluster network policy, right? So
I was just muting myself. Yes. So for the network policy, as I said, there are 2 phases of this. Right now, as of Antrea 1.6, we already support network policy replication, and I will go a little bit more detail into it. And I just have a quick comment actually for Jiajing, because I think Antrea cli, with all this, set leader, set member cluster or off-board member cluster will be a really, really great feature. But in terms of, for the kubectl, right? So if you have a kubectl get resource import and export, if you wanted this to display additional information such as cluster ID, stuff like that, maybe we can also have kubectl do it for us as well, in addition to mctl. Because I know that for the CRD definitions, there's a way for you to set additional printer columns, and those will be something like a tag you run on the CRD types. And if you write something like that, when you do kubectl, it will actually print out more columns with specific fields that you want, so the user can get this information not only from mctl but from kubectl as well. It might be a really cool thing to look at as well, so that when we get resource import and exports, there are way more information than it is now. This is something probably to look into too. Yeah. So right. So we're talking about the policy replication stuff. I wanted to sort of quickly get into the introduction of this feature, so that we have the background knowledge on what this feature is doing. First of all, Jiajing has already gave us a really good overview of how the MultiCluster works, the leader cluster part and the member cluster part. So essentially, you will have a leader cluster working as a facilitator of things, right? So member clusters are usually where the actual workloads of the MultiCluster environments are running. So if you have some service that's backed by a service in member cluster A, and you have the same service with the same name that are backed by some endpoints running in member cluster B. Now, when you export both services, what will happen is that the leader cluster will watch these service exports and do some internal resource exchanging, and then push down a resource import to both member clusters, so that in both member clusters, you will have this imported resource which you can consume. Now, podding member cluster A then can use the service import to talk to service endpoints in member cluster B. That's how this entire resource exchange thing works. And then this is essentially what the multi-cluster deployment is all about. So this is the basic concept of multi-cluster service. And we wanted to extend this concept to Antrea cluster network policy as well, as in the clusters will go through the resource exchange pipeline, so that each cluster will basically have a same Antrea cluster network policy applied into it. So let me share my screen first, and just give a quick recap on what the Antrea cluster network policy is about. Okay, so let's see. Okay, I think I assume everybody can see my screen right now, right?
Yeah, right. We can see your screen.
So if we go to this Antrea tab, right? So I've mentioned this a little bit before in a couple of Antrea live shows ago, which introduces everyone to the Antrea cluster network policy resource. But I will do a really short recap here. So Antrea cluster network policy is sort of like an extension to the current Kubernetes network policy, in that it is not actually namespace scoped. It's cluster scoped, and it's focused more on cluster admins rather than individual developers. Now, if you go into one of the samples back here, which is called strict namespace isolation, what it does is that this cluster network policy, Antrea cluster network policy, it selects everything in the cluster, and it says that for ingress and egress traffic, unless it's from the self namespace, we will actually drop these traffic. And this works for ingress and egress similarly. So what this would mean is that if you have a cluster with maybe 3 namespaces, X, Y, Z, and after applying such policy, what it would mean is that pods in namespace X can only talk to other pods in namespace X and itself, but it cannot actually talk to pods in namespace Y and Z. And the same is true for pods in Y and pods in namespace Z. So every namespace is isolated on its own. There's no cross namespace communication. Obviously, there are probably some exceptions you want to make for this. For example, in each of the namespaces, you actually wanted to talk to some DNS components, for example, or you want to talk to some system monitoring namespace, for example. So these are the rules, individual rules you can add to the ingress and egress section. But for demonstration purposes, this is one kind of cluster network policy that you can apply to the cluster, and you don't have to worry about no new namespaces that come up in the cluster. So, for example, if there's another namespace called namespace J that comes up in the cluster, in addition to XYZ, you can make the cluster network policy here makes sure that as pods start to spawn up in that namespace J, it is automatically isolated within its own namespace. There's no way that the pods in namespace J can suddenly talk to namespace X. So every namespace will be isolated on its own. This is essentially very useful when the entire cluster is used for something like multi-tenancy, right? So a namespace is a tenant, and you don't want tenants to talk to each other, basically. So this is the Antrea cluster network policy resource. Now, how this fit into the multi-cluster use case is that imagine you have a lot of clusters which formed a cluster set, but the tenant isolation rule still applies, right? So in multi-cluster deployments, there is a really interesting concept called namespace sameness, which means that if you have cluster A, B, C, and in each cluster, you also have namespace XYZ. So the namespace X in cluster A essentially can belong to the namespace X in cluster B as well. So the tenant who owns namespace X might be the same guy, and the tenant who owns namespace Y might be the same guy. But those namespaces can be spawned across, a lot of clusters in the multi-cluster space. This is how multi-cluster deployments enable use cases like that. But the same user story applies, right? So if you think about this, in each of the clusters of a cluster set, the admin might still want to have tenant isolation, meaning that they probably want namespace X in cluster A cannot talk to namespace YZ in cluster A. And namespace X in cluster B cannot talk to namespace YZ in cluster B. The same user story still applies. So how you will achieve this without any resource export import will be as easy as you're going to the first cluster of a cluster set. So in Jiajing's example, right, just now, right, you need to basically go to the east cluster and deploy a cluster network policy, which says, I want strict namespace isolation, right? And you apply a cluster network policy there. Then you go to the west cluster and then do the same thing over again. Now you get a namespace isolation for all the namespace in that cluster. And imagine you have 100 clusters in the cluster set. That will be really a headache to do that. So just like the Antrea in the future will make member onboarding and offboarding stuff like that more easier, with just a CLI. The ACMP replication is designed to make replicating the same policy across all clusters more easier than manually deploying all the resources in each of the clusters. Am I making sense so far?
Yeah. I think I understand what you're saying.
Okay, cool. Sounds good. So I guess let's look at how the resource will look like, so that people get a more clear idea on what I'm talking about. I have actually an environment here as well, and I'm looking at so in the terminal here, if you go get pod, and you can see the multi-cluster controller running, and we have a bunch of agents. So this is actually a leader cluster that is responsible for all the resource import export exchanges. So this is like a facilitator of the resource import and export. And then this is a member cluster down here. So if you do to kubectl get pod wide, you can see I have example pods that are workloads which are actually running on the member cluster, and this is the leader cluster. So what the policy replication, how the policy replication will work is like the following. So if you see here, we have a test copy span resource export here, which tells you how we deploy a policy replication. The policy replication is essentially a resource export deployed directly in the leader cluster. And down there, there's nothing really fancy except for all the cluster network policy. So for the cluster network policy, you want it to actually appear in each of the member clusters. You just laid it out here. So this is the spec of the actual cluster network policy that you want every member cluster to have a copy of. And you wrap this up in a resource export, and you deploy this resource export in the namespace which correspond to the cluster set. So each cluster set in the leader cluster will be, will be managed by a single leader cluster namespace. So when you deploy a resource export to that specific namespace, you will make sure that every cluster under that cluster set will basically get a same copy of the cluster network policy as we just shown before. And if you look at this cluster network policy, it is also nothing fancy, right? It applies to every namespaces in that cluster, and it basically says that I wanted to allow nothing but I wanted to allow traffic from nothing but the DNS components and pods from my own namespaces. So, which means that if you have this cluster network policy applied to this cluster down here, what will happen is that the default the pods in the default namespace can only talk to each other, but they cannot talk to the backend namespace. Similarly, the pod in backend namespaces basically cannot talk to anybody but itself. Also, they can talk to the kubedns components. Sorry. They can talk to the kubedns components, which is listed here, right? So they can talk to DNS and they can talk to itself, but they cannot do cross namespace communication. So I'll quickly show how this will look like. So if we do a sudo kubectl apply test copy span resource exporter YAML, and you have this policy replicated. What I mean by that is that if you see here, if you get the ACMP in the member cluster, you will see that the MC controller has actually created a copy of this ACMP on its own. If you look at the ACMP more closely, it has the same spec that we have provisioned for this specific cluster. And how it will work. How it will work is that if you look into the pods in this cluster, right? Let's pick client, for example. So if we go into the client, let's go inside client. Let's go inside this guy and give me a bash window. So we're inside this guy, right? So as I said, the cluster network policy should prescribe is that this guy can only talk to whatever pod in default namespace, and we verify that by curring maybe this guy, and we see the Nginx welcome message. But on the other hand, if you try to reach to pods in a different namespace, this gets denied because of the cluster network policy in play, right? And to verify that, we can simply just do kubectl delete test copy span resource export. Now that in the leader cluster we deleted this resource export, this means that for each member cluster in that cluster set, there will no longer be that ACMP applied to all the clusters. And you can verify that by getting the ACMP, and you see no resources found. Now, if you go into the client pod again, you should see that it can not only talk to what's in its own namespace, but it can also talk to what's in another namespace. So this is the default behavior for Kubernetes cluster, is that every pod can talk to another pod without additional routing or stuff. But it was the ACMP replication that prescribed that ACMP for each of the cluster that made this possible. So it made the namespaces to be isolated with each other, essentially. And this is just in one member cluster. But if you have 100 member clusters, you can go into each of the cluster and then see each cluster will have this member isolation, namespace isolation effect, because each cluster essentially gets the same policy applied in the clusters. So this is basically the demo for this feature.
Okay. Let's do a quick summary. Oh, by the way, do you have like anything else you want to share with us?
Oh no, I
Okay.
can actually stop sharing. So if you have a diagram or something that you've drawn,
Yeah, we see this diagram in the previous episode when we talk about the MultiCluster service. So at that time we said that if the user want to export a service, they need to create a service in the member cluster first, and then create the service export manually, right? So after this service export is created, the Antrea MultiCluster controller will sync this export to the leader cluster, and all the other multi-cluster controller will see the resource import happen, and then they create a corresponding service in their own cluster.
Mhm.
But so this is the workflow of the multi-cluster service, and so this time we're talking about
Right. This time we're talking about essentially skipping the first part, which is creating a service export and then have the leader cluster pick that service export up. This time we do this by directly creating a resource export with the cluster network policy spec. And let me explain why this was a decision. So the reason why we have a leader cluster is that we sort of like have a trusted entity to be the cluster set admin, right? So we had this leader cluster so that it manages all the members of the cluster set. There are a lot of use cases of the multi-clusters, and in some of the use cases, the persona might be the people running member cluster 1, and the people running member cluster 2 might not be the same admins. They needed to sort of like coordinate each other for the multi-cluster to work. They cannot just be like, I wanted to create whatever namespace I want in my cluster, and if you decided to create the same namespace with the same name, then you're screwed, because multi-cluster will recognize these namespaces as the same thing. So they really needed to coordinate with each other. That's the point. But for the cluster network policy, this is another level of security concern. What I mean by that is that think about someone who go into member cluster 1 and created a ACMP. And then they suddenly decided that, hey, I love this ACMP, right? It is really restrictive. It blocks every pod's ability to connect to DNS or anything. We just have this entire cluster on lockdown, basically. And this guy says, hey, I wanted this to be exported to all member clusters. So they will just create a resource. They create a ACMP export, and then the leader cluster pick it up and then replicate it to all the member clusters. Now, all of the sudden, some traffic that's running on the different clusters might break down because of this. And people will then realize that this is because somebody has exported a ACMP, and then it's already automatically imported into my cluster, which I might really want, right? So this will not be a very good experience for the multi-cluster usage. For the service export, it's totally fine, right? So if somebody actually exported a service that the other people doesn't really want, they can simply not just consume that multi-cluster service, and this is perfectly fine. But for ACMP, we needed to be a little bit more restrictive than that, because if you have an ACMP that's really, really restrictive, and you just blindly replicate it across all the clusters, then you're really, really affecting traffic in all of the clusters. That's why we are having this only being able to create it by the leader cluster, because we trust the leader cluster to be managed by a cluster set admin who knows what they are doing. And when they apply a resource export with a cluster network policy that he or she believes will be suitable for all the member clusters, he or she will know what he's doing basically. And all the member clusters then will have the same copy of the policies, which in most cases should be a very basic security guideline for the clusters. But individual members should not basically create an ACMP and just have it replicate across our cluster. So just to sort of like summarize, for service to be exported into different clusters, you need to, one, create a service export, and two, the leader cluster will pick it up as a resource export, and three, the leader cluster will translate into a resource import, and four, it will push down to individual member clusters as a service import. So there are 4 steps there. And for the ACMP replication, the first step is no longer necessary because individual member clusters cannot create an ACMP export per se. So the cluster set admin will be responsible for creating a resource export directly under the leader cluster for the ACMP spec that he or she wants to replicate. So this might be a little bit hard to do manually as well. So we are considering in the future maybe we wanted to add some tooling to make this process a little bit more easier. What I mean by that is that instead of deploy a resource export YAML, maybe we wanted to have additional tooling such as AntCuttle, for example. Let's do something like AntCuttle replicate this policy for us, and maybe we will have some tooling like that. So the cluster set admin will have an easier time, replicating all the clusters, replicating the policy across all the clusters. And yeah, that's basically an overview.
Yeah, so it's like all about the security control that only the cluster set administrator has the access to create this ACMP export.
Yes.
So that each member cluster only can control their own cluster, and whatever they do in their member cluster, it won't influence other clusters, right?
Yes.
So there will be like a gap between the leader cluster and member clusters. That is like different people have different different rights to do the different things.
Right. So as going back to the example that Jiajing just shared, we were more expecting for people who deploy the multi-cluster environment like that. So maybe only the admins have control of the leader cluster kube config that's generated, right? So you cannot just be a member cluster admin and you have that a leader cluster kube config, and you can go inside and just do anything you want. So this is a control. The leader cluster should be a controlled access, and only the leader cluster admin should be creating these policy replications, but not the member cluster admins.
So about this ACMP, so what is the priority of this one? Is that whatever priority that defined in this ACMP export, it will be the same with this?
Exactly, yes. This will be exactly whatever you specify in the ACMP spec in the export.
So if there's like other ACMP or other network Kubernetes network policy in the same cluster, they will like influence each other by the priority, right?
Oh yeah, that's a great question. Yeah, so the priority thing still applies. So essentially, what this does is it is simply applying a ACMP with a given spec into the clusters. Now, if there are other ACMP in the member cluster, they will definitely interfere with each other. Maybe some might rank higher than the existing ACMPs, and some might rank lower than the existing ACMPs based on the priority of each ACMP.
Yeah, right. So the priority things also works here.
Yes.
And the each cluster's admin has the ability to override the basic ACMP if they have higher priority. So, which means that it's not restricted to, which means that all the member cluster can have different ACMP, even though there's like some ACMP export which send out the same ACMP to all the clusters.
Right. It really comes down to what ACMPs people in each of the position can create, right? So if the member cluster, if the leader cluster push down a emergency tiered ACMP, and in the admin of a member cluster, they're basically told that they should only be able to create security ops or even application level ACMPs, then maybe they can never override what the leader cluster pushed down to them. And this whole thing. If you are talking about access control and everything, it definitely all boils down to RBAC in the end. But this just the policy replication is just a framework essentially for the admin to be able to make sure that there's a same ACMP that exists in all the cluster and cluster stuff, and that's basically it. The other relative priorities and stuff of the ACMP will just work as a single cluster ACMP. So.
Okay, sounds good. Is there? Let's see if there's any question from the audience. Is there like any question from Jiajing? Do you think that it's clear to you?
Yes, thank you. It's very clear.
Okay. Okay. There's no other questions from the audience, so let's let's sum up. Let's ramp up this episode. So a little bit heads up is that from the next episode we're gonna focus on other Kubernetes networking topic. It may not be related to Antrea 1.6 or other Antrea version, but it's still in the Kubernetes area. So for anyone who are interested in the Kubernetes networking, the VMware's product and Antrea itself, you can like find the previous episode in our channels. And if you like this kind of contents, please consider liking our videos and subscribing the channel. Okay, I think, is there anything else before we end this show? Okay, thanks everyone for watching and see you next week. Bye.